Next is logarithms. Before we move deeply into logarithms, first we have to look at the relationship between indices and logarithms. What do we mean when we say we are looking for the logarithm of a number? Take for example, if I say I'm looking for logarithm of the number, let's say I'm looking for the logarithm of 1000 log 1000 to base 10. What does this actually mean? The logarithm of 1000 to base 10 is simply saying, taking the base 10, what power do I raise 10 to? And that will give me 1000. What power do I raise, or exponent do I raise 10 to give me 1000? That's the meaning of logarithm of 1000 to base 10. And of course, you will agree with me that this will be 10 raised to power 3. That will be what? 1000, which implies that the logarithm of 1000 to base 10 is equal to what? 3. Now, looking at this very well, you can see there's a direct relationship between indices and logarithm. I can convert a logarithmic expression and write it in indices form. Here we have logarithm of 1000 equal to base 10 equals to 3. This can be transformed into this as 10, the base, raised to the power of 3, which we have there, equal to 1000. And that's exactly what we have here. And if I have an expression a raised to the power x equal to y, it's the same thing as saying the logarithm of what? Y to the base a is equal to x, because I can still revert to my indices form and say a raised to the power of x equal to y. Okay, we've seen this already. That's 10 raised to the power of 3 will give us what? Will give us 1000. So this is the indices form. I can express this straight away that way. And I can say, okay, the logarithm of 1000 to this base is equal to 3. The logarithm of 1000 to the base of 10 is equal to 3. Let's take another example. I have here 81, and 81 is equal to, say, 3 raised to the power 4. I can write this in what? In a logarithm form. This means that the logarithm of what? 81 to the base of 3 will be equal to 4. The power to which we have to raise 3 to get 81 is 4. And from logarithm back to indices, I can say, oh, 3 raised to the power of 4 is equal to 81. Now, this relationship between indices and logarithms can help us to evaluate several logarithmic expressions. Let's look at this. Here we are told to evaluate the following expressions. We have 8 of them, so we'll take them one after the other. First, we are looking at evaluating the logarithm of 64 to base 2. Logarithm of 64 to base 2. As we've just said, what does this mean? If we are asked to find the logarithm of 64 to base 2, it simply implies to what power do I need to raise to get 64? But I can use that relationship of what? Between logarithms and indices to get that value. I'll simply say, let the answer to this, that is, let the logarithm of 64 to base 2 equal to, let me say, something like x. And then I convert this and write it in indices form. And I have here 2 raised to the power of x equal to 64. And that will be 2 raised to the power of x equal to 64. And what's my objective? I want to find x. Now, from our knowledge of solving exponential equation, this is a simple exponential equation. By writing the logarithmic expression in indices form, we have brought out an exponential equation. And how do we solve this? We simply say, okay, let's try to make sure left hand side and the right hand side are expressed to the same base. This is 2 raised to power x. I can express 64 as 2 raised to power 5. And here I say, oh, my x is therefore 5. And remember, that's what we are looking for. We are looking for x, which means that implies that the logarithm of 64 to base 2 is 5. Meaning if you raise 2 to the power of 5, we'll get 64. So we have been able to find the value of logarithm of 64 to base 2. We'll take the next example. That's it there. Logarithm of 64 to base 2 is what? Is 5. 2 raised to power x equals to 64. And then solving exponentially, we have obtained this. Let's look at the next one. Logarithm of 81 to base 3. How do I go about this? Of course, by now, you understand this very well. This is logarithm of 81 to base 3. I say, okay, let this be whatever I like. I can call it k or call it y. Let me use my x, which means I'm looking for x. I'm asked to evaluate logarithm of 81 to base 3. I say, oh, from here, my 3 raised to power x should give me 81. Okay, 3 raised to the power of x is equal to 81. That leads to a simple exponential equation. I say, oh, 81, I know you are 3 raised to power 4. Okay, once again, our x is 4. If my x is 4, then I can simply say here that the logarithm of 81 to base 3 is therefore equal to what? 4. And that's all that we are expected to do. Take a closer look at that. So move to the next. Logarithm of 32 to base 4. Well, this is not a mental sum anymore. Logarithm of 32 to base 4. Remember, we are asked to look for what? Evaluate, find the value. To what power do I raise 4 to get 32? I say, okay, let me just say this is equal to, should I use something else? Let me use m. So I'm looking for m. M is now the value of logarithm of 32 to base 4. Now, expressing this in exponential form or in indices form, I can say that 4 raised to the power of m will give me what? Will lead me to 32. I say, okay, 4 raised to the power of m is equal to 32. But I can't express 32 using 4. But I can use 2. So I change my 4 here to 2 raised to the power 2. And then, of course, everything raised to the power of m. And 32 is 2 raised to the power 5. Okay, fine. Therefore, this is 2 raised to the power of 2m equals to 2 raised to the power 5. Now, solving this exponential equation straight away, we obtain there that the two exponents must be equal. Since left-hand side is equal to right-hand side, 2m must be equal to what? 5. M is therefore 5 over 2, which means if I raise 4 to the power 5 over 2, that will give me 32. So, as we were asked to find, the logarithm of 32 to the base of 4 is equal to what? 5 all over 2. Let's write this out in a neater form. You can see there. That's logarithm what? Let this equal to m. Now, 4 raised to power m is equal to 32. Now, solving this, we reduce our 4 to 2 raised to power 2. Then never 2 raised to power 2m. And our 32 has what? 2 raised to power 5. That equates, or also equates 2m with 5. And we have 2m is equal to 5. So our m is equal to what? 5 over 2. Which means that the logarithm of 32 to base 4 is equal to what? 5 over 2. That's exactly what we were expected to do. Let's take one more for this video clip. The other 4 we'll take it in the next video clip. Here we have logarithm of 625 to base 125. So, okay, let me say let's logarithm of 625 to base 125. Let me say let this be equals to k. This is not so obvious in this case. Again, I change this and express it In exponential form, I say 125 raised to the power of k must give us 625. I look at both sides. These numbers appear to be numbers that will be very, very friendly with 5. 125 is 5 raised to the power 3. Of course, everything raised to the power of k. And this is what? This should be 5 raised to the power 4. Yes. Let's cross check that. Now here I have 5 raised to the power 3k equals to 5 raised to the power 4. Sorry, 5 raised to the power 4. Now left hand side equals to right hand side. Both of them are 5 as the base. Therefore 3k must be equals to 4. So okay, my 3k is equal to 4. Hence k is 4 divided by 3. So we can conclude there that we have been able to obtain the value of log of 625 to the base of 125 as 4 over 3. The other 4 questions will be treated in the next video clip. We are treating logarithms, and so far we are using the relationship between indices and logarithms to evaluate logarithmic expressions.